You know, a lot of trading systems out there love to talk about profits, but very few are willing to actually pop the hood and show you their engine. Well, that's exactly what we're going to do in this explainer. We're going inside the Mars Radar V10 system, but we're not going to look at returns. Instead, we are going to dissect its core logic, its risk architecture, and the fundamental philosophy that's driving every single one of its decisions. Let's get started.
So we're going to break this whole system down across 6 key areas. We'll start with its core philosophy on risk, then we'll move into how it ensures the data it uses is clean. After that, we'll look at its council of AI models and its main defense system, the PDRS shield. And finally, we'll see how it learns from history to create a clear, actionable signal you can actually use.
Okay, to really get this system, you have to start with its most important principle. It is not designed to predict the future. Its job is to mathematically contain the risks that are happening right now. And this right here is a huge shift in thinking. The system isn't asking, hey, where's the price going to be in an hour? Nope, it's asking a totally different question. What's the probable range of volatility right this second, and what is the actual quantifiable risk of operating inside that range? This one change in perspective, it's the foundation for the entire architecture.
Look, any advanced system is built on one simple truth. Garbage in, garbage out. You can have the most brilliant AI in the world, but if you feed it bad data, it's completely worthless. That is why the very first line of defense in this architecture is a super strict data integrity pipeline.
The process is really systematic. It kicks off by pulling data from both Binance and Bybit at the same time. The very first filter is liquidity. Anything with less than $15 million in daily volume gets thrown out immediately. We're avoiding market ghost towns, right? Then, the good, validated data gets stored in a local SQLite database. And this isn't just for storage, it's a critical design choice. It creates this solid local warehouse for analysis, and it means the system never has to worry about external API rate limits. Only this clean, verified data ever makes it to the AI.
All right, so once we've got clean data, the next logical question is, how do we analyze it? Just relying on a single AI model? Well, that's a single point of failure. Every model has its own biases. To get around that, this system uses an ensemble. Think of it as a council of 3 different AI minds, each one looking at the market from a totally different angle.
And this council uses very different approaches on purpose. On one hand, you've got SARIMAX. It's a pure statistical engine, and it's great at finding predictable, linear patterns and cycles. On the other hand, you have an LSTM, which is a deep learning network. It works more like a memory bank, recognizing really complex nonlinear sequences over time. And the third member, LightGBM, is a gradient boosting model that's just incredibly fast at capturing nonlinear relationships. Put them together, and you've got a seriously diverse analytical team.
So how do you get 3 distinct minds to come to a single conclusion? The system uses what's called a voting regressor strategy. Now, this isn't about one model outvoting the others. It's a meta-model that actually averages the outputs from all 3. And this is purely a risk reduction design. By forcing them to reach a consensus, it smooths out any wild predictions and stops the bias of any single model from leading to a bad call.
And that brings us to the heart of the system's dedicated risk engine, the pump-dump risk score, or PDRS. Its purpose is not to predict where the price is going. Its one and only job is to quantify the immediate risk of a very specific, catastrophic event, a blow-off top, that would absolutely wreck a typical grid strategy.
The final PDRS score is actually a weighted average of 5 different dimensions of risk. As you can see, parabolic extension and the volatility ratio are the heavy hitters, each making up 30% of the final score. They're followed by momentum persistence and beta correlation, each at 15%, and finally, acceleration comes in at 10%. So let's break down exactly what each of these is measuring.
First up is the volatility ratio. This is a straight-up statistical measure, the standard deviation of returns over the last hour. In simple terms, it's just measuring how choppy and unpredictable the price is right at this moment. A high number here means the market is unstable.
Next, we've got acceleration. Now, mathematically, this is what's called a second derivative proxy. But what that really means is it's not just measuring speed, it's measuring the change in speed. It answers the question, is this price move getting faster? Because an accelerating climb is a huge red flag for an unsustainable parabolic move.
Parabolic extension is one of the most important KPIs. It asks a really simple but powerful question. How far, as a percentage, has the current price moved away from its 24-hour average? A big number here suggests an overheated asset, which is a classic symptom of a speculative bubble.
Momentum persistence is all about spotting when a trend is getting exhausted. It calculates a simple ratio. Out of the last 12 hourly candles, how many were green? A market that's printed, say, 11 or 12 green candles in a row is showing some dangerously one-sided momentum, and that's often a sign that it's on the verge of a sharp reversal.
And finally, from a governance standpoint, we have beta correlation. This KPI measures how an asset's price is correlated to Bitcoin, and this is absolutely crucial because a sharp rally that is totally disconnected from what the rest of the market is doing, well, that often signals an isolated and possibly manipulated event. It's a critical flag for spotting high-risk outliers.
So beyond all the real-time data, the system also has a memory. It uses a heuristic engine that looks at an asset's past behavior, and it specifically searches for a history of catastrophic failures to help it assess risk in the here and now.
The whole guiding principle here is that history really matters. From a risk and compliance perspective, the way an asset has behaved during past moments of extreme stress is a very powerful predictor of how it's going to behave next time.
And based on that history, the system classifies assets into one of two profiles. An asset gets flagged as trap risk if, after a big pump, it historically just collapses right past the 0.786 Fibonacci retracement level. That shows a pattern of structural failure. On the other hand, an asset is considered elastic if it consistently finds support at the 0.618 Fibonacci level. This shows real structural resilience, which makes it a much safer profile to trade.
Okay, so after the data pipeline, the AI council, the 5 PDRS checks, and the historical analysis, how does all of this complexity get turned into a simple, clear directive that an operator can actually use?
The answer is a really clear set of thresholds. A PDRS score between 0 and 40 is green, safe for deployment. A score from 41 to 60 is yellow, caution, meaning the risk is elevated. And any score of 61 or higher is red, danger. The directive for a red signal is absolute. The risk of a catastrophic blow-off top is critical. You do not deploy a neutral grid. Period.
So in the end, the system's true strength isn't some single magic bullet prediction. Its real value is in its process, a disciplined, multi-layered framework that replaces the art of guessing with the mathematics of quantifying risk.
And this leaves us with one last, pretty important question. What if the future of automated trading isn't about getting better at finding the perfect entry point, but is actually about getting systematically better at mathematically disqualifying the moments that are just too dangerous to trade in the first place?